everyone's had a great Thursday. Happy User Group Day. Excited to have you all here. Welcome. Cool. So first things first, we would like to begin by acknowledging the Yagara people, traditional custodians of the land on which we meet today, and pay my respects to their elders past and present, and I extend their respects to Aboriginal and Torres Strait Islander peoples here today. Cool. First things first, intro. So, hello everyone, my name's Lucy. Obviously, welcome to another user group. I'm very excited, as you can see. Well, if you don't know who I am one of the co-organisers of the event. I am an ops team lead at ThoughtWorks. Been at ThoughtWorks ex-iTalk for about 7 years now. In addition to that, I'm very much a fan of coffee, a pure coffee addict. If you want to bring cake, coffee, happy days, way to my heart. And then also, I'm a massive dog mum. So if you ever come up to me, you want to chat, network, feel free to show me your pets or children. I love families. They're so fun. Awesome. Okay. We also do have a few others around today. So around sides, we've got RBK, who's over in the corner, Alan, who's over in the back, and then we do have Mark as well. If you do have any questions about the night, wanting to speak, any feedback, please feel free to reach out to the four of us. We're more than happy to talk. And additionally, if you do looking for the toilets, please make sure you go out of the glass doors and follow around the corner. And in an event of the emergency, we just want to follow one of the AWS guys. Look for the people in either the blue or yellow lanyards. Happy days. Cool. So we've got a big night ahead of us. So the first one is we got our What's New on AWS, presented by Troy Kirkland, who is a solutions architect manager at AWS. Next, we're going to be presented on the AI in the Cloud, Heroes, Villains, and Security Strategies by Andrew Longhorn, a senior solutions architect at Trend Micro. And then finally, to wrap it all up, we're going to be talking through global reach, local speed, and optimizing AWS deployments across regions by Andrew McClenaghan, a senior principal engineer at Atlassian. Up and coming. So we do have, as we're a community, we want to talk about the other community events that you guys can go to. So the first one is the Brisbane Serverless Meetup. So this is about every 3 months, usually over in the Valley. The current date's still TBA, but if you do want to get involved, want to talk, go talk to Boyan. He's more than happy to help. The next one is our lovely Gold Coast user group, also every 2 to 3 months. The next event is on the 8th of May. And if you do want to talk to someone, Dimitro, who is over there, please go talk to him. He's more than happy to take questions, let you know if you guys want to talk. Next one is the Brisbane Databricks user group. This is scheduled for next Tuesday on the 25th of March. Feel free to reach out to Wilbur Tong for more information. And then finally, wanted to bring up the AWS Community Day hosted in Brisbane on the 15th of August. So we've already talked about it, but we have confirmed our date, which is the 15th of August. And we're also going to be presenting the day at the Brisbane Convention Centre. Cool, over in South Bank. So save your dates, please come along and join. We're going to be starting to open calls for speakers soon, and we've also started to confirm the sponsors. So it'll be an exciting day, so please mark your dates, come along. Cool. Next section is jobs. So we do have a few jobs around in the market, so primarily on our partners in AWS partners around Brizzy. So we have a few from Mantle Group and Idea 11. Feel free to look them up, apply, ask around. We do have some Idea 11 folks around, and I believe we also have some Mantle Group folks as well. So feel free to find them, talk to them. And additionally, we do have Steve from Atlassian here today, over back. So if you're interested in talking about Atlassian, working there, go reach out to Steve. He's more than happy to talk to you guys. And finally, let's actually get started. I'd like to invite up Troy to the stage and start to tell us about what's new on AWS.
First thing I'm going to cover is artificial intelligence. So if you've got any questions, am I being recorded? Is first my question. Yes, I am. Okay, so I'll try and stay on PR for some of this because some of the demos have actually come from my day job. I'll try not to create too much.
You don't have to publish it if it's a problem.
Oh, no, it's not a problem. We talked on the way from the pub, so I'm okay. And so I just want to go through some of the things that we have announced. They're either new for AWS, they're either new in Australia, Sydney and Melbourne. And if you look in the bottom right corner of most of the slides, we'll show you Sydney and Melbourne if that's where they're new because we've globally expanded. But the first one I want to cover is Amazon Q Developer. We have the CLI option for this. Until about 48 hours ago, I was against it. Cookie and Mark taught me maybe I shouldn't be against it. So I'll show you what I did with it is probably the first thing. Command line interface, hopefully everyone knows what that is. Otherwise, I am really stuffed. Open up chat. And so what I did was I asked Amazon Q CLI a question that a customer asked me a couple of weeks ago. Ooh, shivers. Okay, cool, make sure that works. Which was? Oh, come on. My eyesight is not great. Here we go. Oh, shivers. Apologies for the old people in the room. Come on. Okay. So, real customer question, medical imaging company, they've got a traditional system that they want to connect. The traditional system supports one protocol, DIMSI. The Amazon health imaging system that we provide does not. And so I just went through and asked Q. I didn't use the CLI for that one, but I have learnt in the last 2 days how to use it. What should I think about? And so it answered the question the way I asked the customer. And we went through some bits and pieces there. And so they covered off their bits and their needs. If I can get my mouse going in the right direction. The next question I asked them was, what would it take to actually change? From the protocol side, QCLI comes back with some of the really interesting things. Not only does it give me the technical response, it actually gave me some of the regulations to think about. Medical images, protected, not something you want to get wrong. It went through the concept of an adapter. So for those who are dealing with this sort of information, the way to solve it is to create a DIMSI adapter, which I learnt from this. And I went through and thought, well, that's pretty cool. Asked a few more questions, but in the time I have, all I did was then say to it, can you just create the code? I prefer Python. I need a CloudFormation template, and I need to show someone. Can you just create the XML file that I'll then take into Draw.io and go through and do that? And so it's now going off. One of the things that I forgot to do was /auto-accept, /accept all, which will then go through. I don't know if I can do it here. Learn together. Cool. Let's do that again. It'll go through, it'll actually create the files, the README, the Python code. If you want it to run commands, please understand what you're telling it to do. You're giving it autonomy. Next thing you know, the Terminator, we've seen the movie. It's going to go off and create the repo and go from there. So I'll leave that running in the background. Like every good chef, I created one earlier, which was which you can't see, but I can see. In my favorite IDE. So we're now switching across to Amazon Q in Visual Studio code. And what I've got there is I've got the resultant Python code from before, and I actually asked it here, do you mind doing a code review on your own code? So it does a code review. Thinks it did a pretty good job. Pretty sure it can do a better job. And so the next thing I do there is ask it, well, it actually didn't do a good job. It's hopefully going to do a bit now. Paste. Just fix it. So it's actually going to go now and create a brand new Python file that I will then have to create a new file in Visual Studio, copy it in, job done. Difference from the CLI versus this, CLI was just going to create it in the file system and execute. So I felt a better way of talking about what's new is to show you how I use what's new as well. So feel free. All right, PowerPoint. I can show you that later, actually, what comes out of that one. So CLI support Amazon Q, what I did in the terminal shell, and then you can actually take that and use it for whatever you wish. It does execute. Really important. You tell it to execute something, it'll execute something. You tell it to delete something, it gets deleted. So use it with very careful rigor since I've been filmed. The other thing is Claude 3.7 Sonnet's available in Bedrock, available in the Sydney region. Oh, hang on. Actually, can't remember if it is or if it's the endpoint. And so if you're using Sonnet, you've used 3.5, you want to know what 3.7 looks like, I'll show you what I do with it, and I'll go to my workspace for this one. Because I'm hopefully showing you what we're bringing out, but also how some of this can work. I scoured Google. I found a not optimal architecture diagram. I then put that into a tool we have called Party Rock. And what I did have is I've got a Sonnet 3.7, a Sonnet 3.5 widget here. And the prompt is basically, tell me what's in the image, what can you see? I want to know all of the AWS services. I want 5 blog posts for each of the services on what should I learn about this. I want some architectural recommendations. And by the way, do you mind just creating an XML file that I can take into Draw.io? And the difference I want to show you is between what 3.5 and 3.7 does and why 3.7 gets really interesting is with the reasoning, it's actually showing you what it sees. So it's really interesting what it sees in the image. It also finds most things in the image. And if I go back to that image here, not exactly the cleanest architectural diagram you'll ever see. It picks up guard duty down the bottom here, S&S. It actually picks up the people, a security engineer and a platform engineer. It does a pretty bad job of following the arrows, but as a human, so do I. So it's not too bad. 3.5 on the other hand, I'm not disparaging 3.5, kind of got 2 services. 3.7, other side, got IAM config, S&S, starts to get a few more of them. If I can scroll down carefully here, at the bottom of this CloudFormation template, and it actually generates the XML that I can then just put into Draw.io. The reason behind this is one of the concepts we had was we set at a whiteboard, we draw something out as an architecture, we talk about it, we go back to our desk, we forget what we've done, it just atrophies. Is you just take a photo of it, send it into a bucket, goes into the front of the pipeline. By the time you get to your desk, you've got a CloudFormation template, you've got some articles to go read, and you've got something you can put into Draw.io. And the reason I put this under Sonnet 3.7 headline, and someone's going to have to keep me on time because I'm way over, is the way it reasons through and its ability to detect is generationally ahead of what I'm finding for 3.5. Nova is about the same as 3.5 from this. From my results as well. These tools are great up until the last part of the journey. The XML file it creates, typically it misses the last 3 or 4 tags. I copy them in, and it just works. Last week, I deployed my first ever no-touching Amazon Q solution, and it did some pretty big things around Dynamo. So these tools are getting pretty close to being a little bit more free. Still generating, but basically what I get out of this is, if I go and look at one I created earlier, it does a pretty good job. So, asked for a leap of faith on, did this really happen? Yes, it did. Did it happen seamlessly? No. I had to put in the last 4 XML tags, and that was it. For some reason, it just doesn't like finishing the last couple of lines on that one. Sorry, I'm talking quickly. Next one. DeepSeek R1 is available fully managed in Amazon Bedrock for those who wish to use it. The thing that makes me kind of interesting is this is the 149th large language model hosted on Bedrock, 16 serverless, 133 by Marketplace. My personal opinion for YouTube is we're starting to see more and more explosion of those smaller models, self-hosted, domain-specific trained large language models, small subset of the public corpus, and your own personal domain information in it. If you're in real estate, hairdressing, a florist, all of those services will start to get quite specific. So I'm watching what happens after this, which is that explosion of not the big people in town, but the small large language models to rule them all. That one. For those following the battle between vector and graph, so we now have support for RAG, so graph RAG, I always get that wrong. It's generally available for you. What would I recommend you focus on and learn in this space? The move from vector-based semantic to relational-based graph, for sure. And if you have a need for this, please just talk to us. It's going to be a very interesting next couple of years as we go from something that is quite simple to do to something that's going to be much more powerful to see land. Bedrock data automation is now generally available, so the ability to use unstructured data. When I think of unstructured data, I don't know about you, but I always think about Audi. And so what I've got here is, rather than talk about it, I'll show it to you. If you want to celebrate and share this spring with Audi, here's a catalog you can download. I fire that into Bedrock, and it signs me out. Oh, this is going to be fun. This is not new. This has always been here. Come on. Oh, I got lucky. Token hasn't expired yet. We're going to do it again together very quickly. So if you go into Bedrock down the bottom, oh, I hate this mouse. Bottom left, we have data automation hidden there. Got the demo. I choose to upload from my computer. I choose the well-named Audi 37-week catalog. Go down there. Generate a result. And so what this is going to do now is it's going to pull apart that document and look for entities and elements in the document and allow me to interact with it based around what it can see, degrees of confidence. It'll find tables and the like. Unfortunately, it's going to go and do the normal job, which I don't really want it to do, but it's just going to pull that apart here. For those of you who are used to services like textract and recognition, the result will look very similar. So it's following some of those same processes. Come on. This is why I pre-built one, sorry. Takes a little while. Once this finishes, I'll show you it's just got confidence what it sees. There's a nice little tick box in the bottom right, which is create a generative AI view of what you see. And so it'll do nice things like it'll actually say, describing the image of the mango, it'll describe what it sees and the like. So if you're thinking about pulling apart unstructured document types, maybe you're working with branding or marketing, or you want to see what the models think your consumers are seeing, this is a nice, simple way of doing that. So if I scroll down to the bottom of this, look at it by element type, it's finding a table. It's got a degree of confidence. So for those of you who are working on real Gen AI, confidence is really, really important. And then it basically can see what it's reading on the page. The thing I like is if I click here, and wait, and I know I have to make it a project. I know. It'll start to give a view of what it interprets, what it sees, and the like. So this is my last demo, and then I'll just go through the slides. So I don't want to take up too much time, Lucy, so I don't feel bad in yanking me. Come on. I'll come back to it. Oops. Database. So for those of you who are trying to find out what's going inside your RDS databases, CloudWatch Database Insights now provides you with a high degree of insight into what's going on. Hopefully it should be easier to work and dive deeper into it. S3 tables are now available in 3 additional AWS regions, including, bottom right, the Spoiler Alert Sydney. For those who are wondering why S3 tables is interesting to us, speed really matters. So 10 times performance, what's S3? Oh, 10 times, cool. Yeah, 10 times performance over S3 buckets, especially since we're starting to see this movement towards Iceberg as a table format. It should be a very interesting couple of years ahead of us. From an AWS point of view, Iceberg is the table format we've chosen for most of our services. It seems to be where we've committed. We spent a little while scratching our heads, but we seem to have decided that's the way to go. And so for anyone who's looking at, so the JSON Parquet war's done, it's now into the table format conversations and choices. So 3 times faster, 10 times higher transactions per second over S3 buckets, for example. Like I said before, Apache Iceberg added S3 buckets. I even heard today that DuckDB has it natively built in. Thank you, Steve. Starting to see more move towards supporting Iceberg across a wider range of the AWS services. As you saw before, AWS Chatbot is now called Amazon Q Developer. Integrates really poorly with Microsoft Teams for those who are using it. So public call. So most of the things I cover with you are for you as technology leaders, nerds, however you want to describe yourselves, at getting used to what works and what does not work. Please tell us what does not work. This is my job, is to actually take what does not work, articulate why it matters to you and your customers, and then ask our service teams to prioritize what they fix and what they don't fix. Microsoft Teams integration with Q Business is an area that we're trying to improve really fast. So if you take nothing away from my presentation in the couple of minutes I've got left, try it out, see what helps you in your learning, see what helps you in your day-to-day work. Please tell us what sucks, and we will try our best to fix it as fast as possible. So we now have that integration to Teams and Slack, never forget your security boundaries and principles. Your chatbot typically executes in one security principle. It knows everything. Deploy carefully. This one is something that I think is super, super interesting in 2 ways. So at the moment, you can now integrate Amazon Q into your M365 applications through your tenant from Microsoft. So you have to be a tenant admin. And what this does is it allows you to write better emails and documents in Office, which, as flippant as it sounds, is actually not a bad thing. What gets super interesting to me, in my personal opinion, is that it gets much more powerful when on the other side of the service, where we have Amazon Q, is supported by your own data. So at the moment, what it'll do is it'll tell you how it thinks Clippy should write the email. You go, cool, got it. But when you start to write emails, which is, I'm just doing my monthly report on the production line for March, can you please show me year-on-year factors and change? When the database and data sources behind changes like this, and we're not unique in this space, Copilot is in there as well, gets really interested on automation and power. So this is one thing we've actually built a prototype on, and hopefully we'll get some traction if Mark can yell at the right people. It's what happens after this that gets really interesting to me. This is about normalization if you're a non-technical user. I get used to AI helping me. It's the reason Apple put 8 more gig into my MacBook Air so they can use Apple Intelligence. It's all about normalization. What happens next is super interesting. Lucy, tell me to show up when you need to. Cool, we'll keep going. Time-based copies, for those of you who like resilience, this is super interesting. It allows you to delay when your copies are now available. You can have a safe duration on that to give you a little bit more of safety in how you are meeting your resilience targets from your employer, and available in CloudWatch metrics as well. M7A instances are now available in the Sydney region. There are 2 things on this slide. The first one is that they're there and they are 50% faster than M6As, which is cool. And the reason for that is bang for buck, also save the planet. So the secret behind our EC2 generations is they become hopefully much more power friendly. And it's a nice way for you, especially in your Scope 3 emissions. The more you use the newer chipsets, hopefully we do the right thing by the planet is the intent. The reason they're faster is because we also put in DDR5 RAM into the instances as well. But I want to have a shout out. So something else that's not new is the Flex family. So if you are making the consideration about how you stay on the current edge of instances, M6 to M7, if you're running M5s or M6s, please consider M7s and please consider M7 Flexes. The Flex type executes between 40% and 95% CPU. If your application's operating consistently into the 95 to 100% CPU, update your resume, it's a different animal. But what it does allow you is to get a 19% cost drop over the M6s. So from a step change point of view, whilst Flex itself is only 5% less cost than non-Flex, when you're going between generations, you can actually get a nice little bang for buck on that one. And I'll finish on this one. So API Gateway, we've been working for a long time on what they do around mutual TLS, cert-based security, so a number of features now available around continuing to make sure API Gateway is the service you need it to be, available in Melbourne. So we're trying our best to make sure we have regional parity between Sydney and Melbourne on that side. And I'm at 20 minutes, which I have to apologise for, but I shall finish there. I don't know what I was going to come back to. I was going to come back to Safari. One second. And so what this is doing, still spinning. Hey, it's not my fault, it's Tim Cook's. That's good. If we scroll down here, in the results, we'll start to get where's it going? I clicked the wrong place. It's going to prove me a liar. Document abstract. Give me a document. It normally works. Here we go. It couldn't be a demo without at least one thing falling over. There we go. Image shows an icon or logo representing. So it's starting to give you interpretations of what it sees, not just what it reads. So from an out point of view, rather than actually just pasting the text, it's showing you what it believes a human would see, which is from a branding and document digestion point of view is important. But thank you.
So hi everyone, I'm Andrew. So I'm a solutions architect with Trend Micro. I've been here 3 years. I know a few people here already, and I apologise because it's been a little while since I've been back here and presented, but maybe that's good for some people. I love building stuff and solving problems. I build primarily in AWS, so I do a lot of learning how things work and putting them together and pulling them apart. My latest claim to fame was I actually competed and led a team in an international AI hackathon in Japan quite recently, and we took out the competition above thousands of competitors. It was a great event. It was a lot of fun. I just want to ask you, because I want to get an idea of who's doing what. So how many people here are actually using AI currently? That's a trick question, right? You should all have your hand up. Like if you Google something nowadays, it'll give you an AI answer, right? And who's building with AI? Like, are you using the code assistants and stuff like that? Yeah, I got a surprise. I do a lot in Xcode, boo. But I sort of didn't get it until I started using Xcode, and it started prompting me with stuff that actually was useful. Like I started typing and went, oh, you mean that? Yeah, actually I do. That was good. So that helped. But who currently now for their work is building AI systems for production, like a real project? Who's doing it? Way! Good, we've got a few. Excellent. Now, who here is interested in security? Boo. Oh, we have some. All right. It's funny, the guys that are building are not interested in security. All right, no, I mean, I'll get there. So, for me, I love what I do and I do what I love. Who does that? Yeah, isn't it a great industry to be in? The guys that didn't put up your hand, look for another job. But we're constantly having to evolve and improve, and there's all this new advancement like we just heard, and it's changing the game. It's changing the goalposts a lot, not just in terms of what you can achieve, but expanding that problem set in terms of security, like new ways that the bad guys are going to get access to your data, new ways that they're going to get hold of your users, make them make a mistake, even if it's not for the company, but for them to lose their money or lose their house, or like there's just so many threats out there all the time, and that's what keeps me employed, and I love it. I don't love that, but you know what I mean. So I wanted to present a bit of a blueprint. This is me going to work. This is my castle that we've built. We're all building castles, right? The problem is that eventually the peasants want to have running water in the viaduct, which we don't have. So we've got to modify the system to let the water in. And of course, it creates a bigger attack surface. Now we know the trolls can get in through that entrance that we made, right? Same thing, the peasants don't just want running water, they want to use AI, right? So what can we do about it? So as I said, the only thing that's static is change, right? Who's starting to get this sort of question coming at them? Right? If you've seen any of these questions being raised, yeah, then they're not unexpected, but a lot of them are new. They didn't really exist as questions before in terms of what we had to take into account. The worst thing is we get questions like, who's using AI in the organisation? Well, everyone is. That's a stupid question. What AI are they using? Well, how can we discover that? You know, what can we do in AI? Hey, DeepSeek's out. Let's build something on that quickly. And then realise that, well, we actually have to put some guardrails in place. So there's a whole bunch of things that occur in the AI landscape that create those new threats for us. Now, I think I had this in here, but I think everyone's up to speed. Basically, you know, AI is the main group terminology about machines doing human tasks. You have the machine learning, which is being able to get machines to be able to do things themselves based on data. Then you've got et cetera, NLP, getting interact in human terms, being able to do deep learning like a brain, et cetera. I'm not going to really dig into that. You know this stuff, or most of you do. If you don't, there's a lot of material on Google that will teach you this. The AI maturity journey looks like a maturity journey for a lot of different technologies. As soon as they come out, we go through this cycle over and over, don't we? We sort of get the awareness and exploration where people are trying to do things, and then they start experimenting without guardrails and going off and putting personal data up in the cloud thinking, gee, this is wonderful. And then adoption and integration, and then the guardrails come in, and we've got to get through to that endpoint. Who thinks in AI they're up at the leadership and advocacy at the moment? I'm going to put my hand up. Because the only reason is because in terms of AI, Trend Micro has been doing it for like decades. We have had AI in the platforms. We've been looking at how AI interacts with things. We look at how we can use it in our platforms to actually improve what we do every day. And it's not just the LLM. We've been doing it for a long, long time. So I would say I'm an advocate. I wasn't a short while ago, but I actually am an advocate now. Now, introducing risks to the organisation. Where are the risks? Well, they're pretty obvious, right? We have risks on data. Risks on things like being able to hide the data that's sensitive, being able to protect it. If you've got stuff sitting on S3 buckets that acts as input into your models to be able to generate the better answers that are based on your PII or your customer data or on your staff systems or on your code base, whatever it is that you've got there, it's all sensitive information. What about insecure outputs? Things like systems that connect the data and give you information back that you shouldn't have access to because it's bypassing. It has like a super user capability to generate these answers and give you something back that you shouldn't have access to. Right? Extortion, deep fakes, right? All that sort of thing. But that are based a lot on data models. Where's the best data model for deep fakes, right? LinkedIn, Facebook. You can just go, hey, I want to copy this person. Great. Point it at Facebook, you get everyone. The models, prompt injection. Who's heard of most of these terms? Denial of service, well, obviously, similar to existing, right? Hallucinations, misalignment, poisoning of data models. All of these have been proven in production. They're not are theoreticals. These are real threats. So the data is about the knowledge, the model is about the brain, and the management is your overlay in terms of what you should be able to provide as a protection mechanism to ensure that you're working within those constraints, like your compliance, like your HIPAA, your GDPR, PCI, whatever it is that you've got as protections. Now, when we think of a typical application, you'll see that a user interacts with an assistant. The assistant might farm out certain work to do or put things into an API request. It will then do some processing on-prem in your cloud with your local stuff. It might farm stuff off to like ChatGPT or some sort of OpenAI, and I shouldn't say OpenAI, but you know what I mean, and come up with a result. Now, at all these points, there's different things that can happen, right? So things like when the user creates a request, I already said about being able to get information out that they shouldn't be able to get, or uploading information that they shouldn't share, because it might be farmed out if it's not controlled out to the cloud SaaS versions of AI. You've got different things that can happen on the way through. Oops, sorry, I thought that built out more. So things that can be in prompt injection at the assistant level, you can get different vulnerabilities, different types of ways of the data getting accessed and the whole model's being compromised through that whole process. So when you think about this, you think about, I asked about who's interested in security, right? And I made a joke that the guys that are developing aren't interested in security and the security guys are blocking development. That's a common age-old joke. We're trying, seriously, for all the developers, we are trying to be not blockers, we're trying to be enablers. We're trying to say, how can we let you innovate at the speed of light, or speed of whatever it is, the speed of innovation, but do it in a way that's safe, so that you don't launch something and then suddenly have a catastrophic failure on the news where suddenly all the PII gets leaked. I remember ages ago, when I was in app development, there was an app that was developed that allowed parents to look after their children by monitoring where they were. And then it was later found out that the RDS database, I think it was, no, I won't blame RDS, it was a cloud database, was actually publicly available. And therefore, the predators could find out where all the children in the US were. Now, this is not what you want to happen. You want to innovate, but do it with a protection layer. So we are trying to get AI innovation balanced with security and be able to provide, like I said, the innovation, do risk assessments and do the stuff the security guys need to know to keep and tab on things, and try and shift left as much as possible so that things that are security issues turn up more like bugs. So you know early in the process what you've got to fix. It doesn't come and bite you in the butt later. So what do we advocate? Planning, just so you can see it, planning a defence. You've got a plan. It's like taking on any new project. You can't pick you don't want to launch into it and just go, hey, I know Pascal, so I'm going to write it in Pascal, right? I'm showing my age now. You want to be able to pick the right technology, otherwise you have massive technical debt when you have to pivot, or you have to change, or you have to introduce the security layers. So we're just asking you 6 basic things to bear in mind when you're building your applications or providing access to applications, so that you are protecting yourself or future-proofing yourself to make those changes, right? So this is a 50,000-foot blueprint, that's what it says. It's essentially what an application might look like. You've got things like additional cloud services that are the things that wrap around your AI. So you might be spinning up stuff with SageMaker or Bedrock, but you've got additional stuff in your infrastructure, like your cloud storage, you've got your VPCs, you've got your whatever it is, the EKS, whatever you're running in there to run your application. Then you might be using inference platforms, or you might be going direct. You might have different services. You've got your storage, you've got your external users that might be, and they're all external to the system, right? So there's all your users that might be developers, just staff, they might be attackers, or anyone out there. And each one of those things creates a possible problem. And part of this could be on-prem or hybrid, or you might be using SaaS in combination. So starting with the first part, data. So how do you secure your data? What are you doing to secure it now? A lot of people are just going, yeah, well, we make sure it's not publicly accessible. Well, it's a lot more than that. So there's things like, as I mentioned before, not just the exfiltration and unrestricted access, but being able to, and these are a simplification of the multitude of issues that can be here. They're like a summary that umbrella those terms. Doing things like monitoring, classification, doing posture management to be able to discover and understand data, being able to search within your infrastructure and discover where data is and what should be protected, because that knowledge helps to drive down the chain. If you understand where that is, and you don't have to go around manually classifying this stuff, right, like we used to 10, 20 years ago, there's better ways to do it. And if you have that in place, then you can monitor things like uploads and downloads and be able to intercept those communications to stop those leakage, right, either internal or external. No, where'd I put it? Here. So you might have it in S3, you might have it in RDS, you have different types of data that's being consumed by Lambda functions, so you've got serverless in there, you can't put agents on everything, you might need some sort of agentless capability to scan this stuff. And then again, the same flow that I showed before. What you'd really like to have is something, as a security person, you'd want something like a nice dashboard down here, right? So being able to present up a discovery across your entire infrastructure of where your data is, where your vulnerabilities are, where your infrastructure that's most vulnerable is, all those sorts of capabilities in one interface. Now, there are, of course, capabilities to do that from a multitude of vendors. We're one of them, but we think we do the whole gamut of what I'm showing you. That's why I'm here talking to you, right? So things like credentials, over privileged access, any of those sorts of things. The second stage is securing the AI model in the microservices. So here, we talk about microservices because nowadays it's pretty easy to spin things up in containers, or you might want to just spin up like we were talking about with the DeepSeek. Like it's so much easier rather than in the past where you had to do provision GPUs and get different systems to try and utilise that resource. It's just easier to do it now. So the villains here are around things like vulnerabilities, being able to get into those models, being able to do data poisoning, and also become a launch pad. So if you have a container that you've spun up that has a vulnerability and it becomes a landing spot, people could then go from there into the rest of your infrastructure with lateral movement. So the heroes here are the ability to do runtime, real-time monitoring of vulnerabilities and understanding every single container in your EKS or your Fargate or whatever it's in, doing vulnerability scanning both pre and post deployment, so you understand something that you deployed yesterday that was secure is now not secure today. Being able to take action on that and being able to, say for example, you deploy a huge fleet of containers today and you get those vulnerabilities, how do you monitor each single one and know which ones have that vulnerability? And how do you then mitigate that and do it in a way that you're not taking down the system or creating downtime or creating a bad user experience, right? You've got to be able to cater with that on the fly, in real time, basically. The other thing here is being able to get correlation. So there's cross-correlation we talk about in terms of logs. This is really important because anyone who knows in the security industry, there's two types of activity that you see typically, or the way we break it down. One is a security event is something that has been identified as bad, and so at that point in time you block it because it's bad, right? There's a blurry space because we deal a lot with users that do bad things unintentionally but to achieve a goal, and they're not actually bad in their own right, and that's called just a, what do we call it again? Mind blank. Come on, Kai. There's a security event and then there's just activity. Yeah, activity. So activity is more like things happening all the time. So that's why SIEMs exist, because they pump in all the activity to try and get what the malicious thing that is happening under the covers. The way they work is by correlating these things that are in of their own right okay, but the fact that they're doing them like this leads to this person is attacking us. So it's really important to get things like your VPC flow logs, to get your all your logs out of CloudTrail, to get your information out of, out of your WAF. and put that all together with network telemetry to understand if people have jumped into the network and they're doing bad things, because they live off the land. They don't put bad things on there. They just do bad things with the real tools that you've already got there. So that's important to understand, to be able to capture that sort of information, that sort of breach. I didn't start my timer. Whoops. So securing the AI model is all about getting that telemetry in, getting the different vulnerability information, being able to scan for vulnerabilities, understand them on all your infrastructure, be able to feed that all back and understand when you're under attack and be able to mitigate that attack. So this third one's pretty obvious, right? Securing your infrastructure in the cloud. Like, who thinks we've succeeded? Exactly, right? Well, we've been talking about this for decades, or for a long time, at least 10 years. It's about cloud misconfiguration, typically. So there's so many services that are available, which is a good thing, but it's a bad thing. So you've got to make sure that whatever you're putting in place does that continuous assessment and continuous monitoring, not just the guardrails and being able to shift it left into your pipeline and do infrastructure as code to build things out that are inherently secure because they don't pass those checks, but what happens if someone gets in there and tweaks something? You had over-privileged user that you gave access. I've not spoken to many organisations that actually shut people out from admin on the AWS infrastructure, right? They're trying to get that way, but you still have these super users that jump in and do what they like. And so as long as that's there, you're still going to have potential errors being made. So we've got to get to a point where you can get what your best policies are, what your AWS well-architected best frameworks are, and analyse your systems real time against those to say, how do we fare? Are we being cost effective? Are we being secure? Are we doing it? Like, security is the main call, but it's everything there. You have to be able to utilise these systems and not open security gaps, as well as waste money, et cetera, right? So if we look again at the typical architecture, you've got data stored in S3 being processed by Lambdas. You've got an AWS app runner, Bedrock, SageMaker, whatever you're doing in there. So the important part is that cloud security posture management, right? And I've got to remember this one. It's a new one for me. Cloud infrastructure entitlements management. Who knew that one? Put your hand up, because I just told you. So these are the capabilities to be able to set a framework and analyse your systems ongoing, real time. So when something changes and you suddenly have a user with elevated privileges that shouldn't have them, it flags up on a console to say, hey, why has this guy got extra privilege he doesn't need? So this is what these systems do. And being able to do agentless vulnerability and malware scanning, because you're not always going to be running off like an EC2 or something like that. You're going to be running potentially serverless. So you've got to be able to understand what those vulnerabilities are and report on them and manage them and be able to mitigate them. Now, I know I'm blasting through this, but I can probably give a copy of these slides or something afterwards. Yeah, okay, cool. So what you want is this is the dashboard, the utopia for the security guys. The guys in security, you show this to them, and they go, wow, that's fantastic. Because you get in one view, you sort of get your compliance. You understand what is actually potentially going wrong. And if you see any red here, you sort of go, ooh, okay, I better check that out. The rest green, I'm not so worried about, right? As the dashboard should be, right? The second part of it is when I was talking about the cloud telemetry, so like the WAF, the cloud trail, the VPC flow logs, all that telemetry feeds into like an XDR. So I think a few of you know what an XDR is. Essentially extended detection response. It correlates all those things, uses AI in a lot of the models to determine, hey, something is going wrong, and presents it to you rather than knocking it on the head in case it's actually legitimate, for you to then investigate and go, okay, here's all the findings. This is what we know about the event, all the things that occurred together, why we think they're bad, and what you would probably do about it. And then you can take your action on that and mitigate it, right? As well as things like attack paths, being able to understand if you had a vulnerability on an external facing service, and perhaps that has certain privileges or roles that are associated with it that give access to the AWS RDS database, then there's your attack path. Someone could come in through that to get to your sensitive data. So it's important to understand the context of all this stuff to be able to mitigate and focus on what's important, to be able to remediate. So as well as collecting all that, who's heard of MITRE ATT&CK? Yeah? Who knows what it is? Yes. Sometimes that's not like one-to-one relationship, right? So MITRE ATT&CK's a really good, it's being developed as a framework to help standardise the communication and the understanding in the security industry. It's a really good tool. It helps people who are new to the field to understand what's happening and also to see where in the whole attack flow things could be going wrong and why. So any sort of tool that you're doing this with, like things like the correlations or the events, the vulnerabilities, the different activities, they should all be mapping against this so that you're talking a single language to be able to understand it. It's great when you have a team working on an event and they all look at it and go, oh yeah, that's a T001, blah, blah, blah. Then they can go, right, we all know what we're doing straight away. Okay, number 4. I've got 6, right? So halfway. 3. Secure your AI applications. So this is around interactions with the applications by users, whether or not they're an internal application or an external SaaS or hybrid, whatever you're interacting with, right? This is around the villains being things like, actually, I think I have a couple of villains on this one. No, not, it's the next one. So untrusted programs attempting to modify unprotected AI files. So perhaps you're running an AI model, part of it might be resident locally, it might be in your infrastructure, and you might have something that goes onto the developer's machine that then modifies the configurations, right? So it's like a sort of a supply chain, but it's not built into it, but it's basically coming through as a sidebar to get into the infrastructure to damage your AI models or make them operate differently. Has anyone heard of that before? Probably not. Yeah, 1 or 2. Okay. So really the heroes around here are being able to identify that suspicious or untrusted process to be able to knock it on the head, to essentially say this shouldn't be happening. Sort of like tripwire, or I think what was the other thing we called it here? Yeah, I've forgotten the name of it. So being able to get developers using the AI app, there's a new file that affects the app or the configuration. You need a way to detect that and then have what effect it is and then be able to shut it down. It's critical that it doesn't affect confidential data that could be on those machines. So it doesn't provide a way for that to be exfiltrated or to modify it so you get false results. AppGuard, that's what I was talking about, AI AppGuard. Right, so these sorts of technologies are referred to as AppGuard or AI AppGuard. It basically monitors any kind of challenge on those or changes on the files from any sort of file process on the AI local application, essentially. So you wouldn't think I won an AI competition if I didn't even know that, right? I had to read it off here. Jeez. But that's how fast it's changing, right? All right, 5th, almost there. Secure your users. Now, we all have to worry about the user, which is always the biggest bug in our system, right? Always. Now, and I don't mean do this, but sometimes that's what we want to do, right? So who's been impacted by deepfakes? And you don't want to admit it. Okay, most of you, all right. And who has heard of someone being impacted by deepfakes? Yeah, okay. And it was a loved one, right? And they go, no, okay. I actually have an interesting story about this. Yesterday, I think it was, or the day before, I rang a support line. And a very helpful young man answered the phone. He said, hi, my name's Bob. I went, well, you're probably Frank, whatever it was. And he says, I'd like to help you. Can you tell me what the call's about? Oh, no, what was your name? That's right. So I answered what my name. And he goes, oh, okay. And what can I help you with? And at that point, I went, there's something a bit off here. He doesn't sound real. But it was a damn good impersonation. Now, the question that popped into my mind was I actually felt quite betrayed that the company tried to fool me without putting a disclaimer on the front saying, hey, this might be monitored for training or education purposes or coaching. Right? It should say, by the way, this is not a real person, but please feel free to act with them. Like I felt like I was fooled. So I actually fell to a deep fake. It wasn't a malicious one, I don't believe, but anyway. So virtual meetings, who's always doing virtual meetings? Everyone, right? Dumb question. And you've heard about a lot of those risks. Everyone has heard about them now, where like the guy, when was it, a year now, in Hong Kong, got convinced to do 25 million transfer by the not CEO that appeared to be the CEO or the CFO. Yeah. The interesting thing about that case was he was actually suspicious, going, why is this guy talking to me? Because he's like way up there. But it was when the other AI guys or whoever else joined the meeting and convinced him that he ended up doing the transfer. Right, so there are technologies that you can put in place to do this, things that sit on developer machines, sit on staff machines, more staff machines, and monitor the video feeds that are coming in and look for the evidence of deepfakes and warn you, just like an antivirus would say, hey, this was a bad Trojan horse file. It comes up and says, hey, this is not a real person. I didn't know if you knew that. Last one, securing access to the AI services themselves. So this is where I was talking about maybe attempting to use an AI service and potentially leaking data. The hero in this case is the AI gateway. So like reverse proxy type applications, and AI gateway is specifically built to cater for web services that are like AI. So they understand things like prompt injection or malicious URLs coming back, or more than just advanced threat and DLP. They're talking about things like, what was the other one I was going to mention? Forgotten. Ask me later. All right. Essentially, what you want to do is a developer uploading some code. Obviously, not a very good developer, right? Wants to know what that does. But this could be secret code or something that is internal to the organisation. You want to be able to block that before it leaves the organisation. So you're gating the exit of that information to, say, your Copilot or no, we shouldn't say that, to whatever AI service you're using. You want to be able to gate that to protect it. Similarly, if a villain is trying to get information being accidental out of the system, or maybe even on purpose, they might ask something like, well, what's the different addresses, names, wages, and everything of all the people? And this is that level of agency that is given to the AI to be able to extract that information. So being able to protect that as it comes back in and say, hey, you shouldn't have access to this. So it's in and out. There's other things like the vulnerabilities. I'm going to get to the end. I'm very close.
Andrew.
Yep.
I have a question. How does it do that? Like, how does it know that I don't have access to that employee data?
Because when you have...
Or does it just block it for everyone?
No. So what we've spent a lot of info. Actually, I'll give you a link at the end that talks about our AI architecture and the Learn framework, which will help explain a few things there. But some of the magic is around the things that if you understand through identity management what access they should have to certain data, and you understand that group classification, then when the data comes back, it can match it on DLP to understand that there's certain things that shouldn't be shared. So it's not very fine granular yet, but it's got the ability to do some controls based on privilege.
So does that mean it's designed around integrations with existing systems?
Yes.
Like AD and things
Yeah.
like that? It's not designed for custom built solutions?
If you had IDP with it depends on how you... Yeah, we can talk about that after, but yeah, it depends on the level of integration and how standardized it is. Like, obviously, if you're using Entra or you're using... I shouldn't say Entra here, should I? I don't know what I'm allowed to say. I didn't get a list of bad words. Anyway, let's talk about it afterwards. Yeah, it's quite detailed how it does it. All right, and then virtual patching is an interesting one. This is a technology that not a lot of people are aware of. You may have heard the term IPS, or intrusion prevention system. So it works by essentially understanding what a vulnerability is and the fact that you would have to execute, say, a malformed HTML request to be able to gain access and execute arbitrary code on the endpoint, right? So the IPS essentially catches that information going through as a packet and drops it because it's not part of standard business capability. So the IPS does that. One of the reasons why we think we're the best in this is because typically we, as part of our zero-day initiative that catches all the vulnerabilities around the world, it catches a very large percentage of vulnerabilities. So we're first to the market to be able to write these rules to protect people. And what it does is it means you're not rushed to then go out and push your patches everywhere and potentially take your system down. you're mitigated in the short term, and then you can patch systems. So basically, yeah, secure your data, secure your models, secure your infrastructure, secure your users, tie them to a chair with things on their eyes, secure the access to the AI services through the gateway, and then, of course, defend against zero-day exploits with mitigations. We have a paper here. Now, you may want to QR that. If you don't trust QR codes because I might be hacking you, then we can get to a different way.
Back one, everyone wanted to screen.
Oh, sorry. You're keeping me honest.
That's all good. We'll have the recording as well, guys.
Yeah, you might have to slow it down. I talk very fast.
Yeah.
0.75. I don't want to stand between people and beer and pizza, right?
It is outside.
Oh, don't say that! Oh, we got 2 minutes.
Yeah.
All right, we got it now? All right, yeah. This one is the money shot, right? So part of what we did in terms of learning from all this and understanding how to put this security in place, we produced this blueprint. It also it's a bigger paper, white paper, it's worth getting, even if it's certain parts that you're interested in. And then it references a thing called the Learn architecture. So that one is related in terms of the Learn being those 5 or 6 main entries that you have to think about. Next thing is we have obligatory marketing slide, right? Which is basically it's free. Well, it's free to try. It's freemium, okay? You can get to it via the marketplace, or you can just search for free trial Vision One. Vision One is the platform. We actually, interesting sidebar between you and pizza, is we actually have one product now. We used to sell lots of products. We don't. We sell one product with a lot of capabilities. It's called Vision One. So when you think of trend, it's Vision One. When you put that in, you can then go, I want to use endpoint, cloud security, I want to do mail, I want to do user education, I want to do phishing simulation, whatever it is, it's all out of that platform. It's it. All right, so now we all live happily ever after, right? Well, a couple of comments, right? You thought we were done. Of course, AI is powering good and bad, just like if you give machine guns to both sides, some use them to attack, some use them to defend. Right? So we are constantly in this battle, and we have to adopt and change and use it as a security vendor and security practitioners and developers to be able to keep ourselves safe. 2 more. Plan security now. Like I said, don't wait till it's out, and it already is. So get going now. Time's ticking. Can't say it any plainer than that. And platform-wide AI mesh. So this is something that we've been working on and has been in the product for a while developing. So in our capability, we have the AI mesh to be able to pull together everything that's coming from all the points into one area to be able to make the decisions. It's not like you're making decisions with half the information. Now we live happily ever after. Thank you.
Any questions?
Hi, I'm Andrew. I've been at Atlassian just shy of 3 years now, thanks to Steve. So I'm a senior principal at Atlassian. That means I look after multiple teams, looking after one particular area. In my case, I look after messaging. Please don't come and tell me about your Jira emails. I know they're bad. We're working on it. We'll get there. I have to call this out because Steve is here. We are hiring. If you're interested in having a conversation, if anything we talk about today is interesting or anything to do with what we do and work on is interesting, please either reach out to myself or Steve. QR code will get Steve to give you a lovely call back and have that conversation. But I'll be around at the end of the night as well. More than happy to have a conversation. But yeah, Steve said I had to put it on there, so there we go. Cool. Going to talk about a few different things tonight. 1, welcome. 2, why is the global reach and problem and local speed a problem for Atlassian, and how do we work through those things? How Atlassian uses AWS, and we'll talk through a little bit about that. I'll talk about how do we scale our deployments and our developers and engineering across the world. And I'll talk a little bit about how we structure services as well, because that comes into this conversation as well. For those that have worked with me have heard, and this is a pretty common phrase, I think, a bit, but definitely hearing me, it's something I personally say a lot, is normally, you are not Netflix, don't try and implement what Netflix does. I'm going to caveat my talk with that exact phrase. You are probably not Atlassian. That doesn't mean you can't learn from what we do. One of the biggest things I learned, for those that weren't aware, I started at iTalk before I came to Atlassian. One of the things I actually saw amazingly well come out of what the work I did at iTalk with much smaller businesses than Atlassian, amazingly scaled very, very well to Atlassian scale. The things you got right at small actually work really well at large. The things you make as mistakes at small make an even bigger mistake in the large space. There are things that we do that don't make sense, and I'll call them out for small people, but in almost all situations, there's an Amazon equivalent or something, or you just don't need it. So try and understand the core reasons. I tried to boil this down to as much of that as I can. Apologies, some of it won't quite apply, but hopefully some of this does for what you guys are looking for. I prefer interactive sessions, as per my question from the last session. If you've got questions, please reach out. Also, I definitely don't have those pretty AI slides that were in the last one. And I hope, to be honest, none of this is a surprise for anyone that's been in Amazon space for a while. Personally, I'm a bit over 10 years now. None of this stuff that I learned at Atlassian surprised me on the whole. We do it at scale, we do things large, but on the whole, it's pretty similar. So we'll talk through it. Cool. Why is this a problem for us? For those that aren't aware, Atlassian has what we do. I'd like to hope you guys know, but just in case, we have Jira, Confluence, large SaaS application. Deployed globally, we have a large list of compliance requirements. So internally, we refer to anything generated by a customer as UGC or user-generated content. As part of that, one of our big compliance pieces we have around the world is data residency, or DARE. Currently, Atlassian, last I checked, or which was just before this, we have 11 locations around the world that you can pin your data to around the world. That is in and of itself a big requirement for our customers. For anyone that's worked with banks, governments, any sort of regulated industry in the world, especially in Australia, you can't have your data leave a particular area. So banks in Australia must keep their data in Australia. It can't go to the US, it can't go overseas. That is the same for other industries, including banking, all around the world. So that's why we do things like that. Covers things like GDPR and stuff like that. So from that perspective, we have customers that exist everywhere, but their data has to live in one particular location. It can't just be shared around the world. That's not a case for everyone, but there is definitely that case for a large number of our customers. Why do we have to deploy globally? As another part of this is we have latency problems. We have performance problems. Jira has known for this. We are working on it. It's getting better every day. We have things in the front end. So how do you interact with the product? What do you do? So moving to server-side rendered, web front end, all that sort of stuff. The closer you can get that to an end user, the faster their experience, the better their performance, the better their outcomes. There's also a fun and interesting one that tends to get missed. Latency and performance also impact on background jobs. So increasing latency increases cost, tends to, and also reduces performance of your system. You tend to end up consuming more Amazon resources if your services are further away from where they need to do, things like that. And that then drives to the last one, costs. For us, at the scale we deploy, every single small change you make doesn't change your bill by dollars. It tends to change your bill by tens of thousands of dollars. I have a team in mind made what I thought was a very small change to one of our services, saved $1 million a year, US. I almost fell off my chair when I realized that a small change in one service that I own was $1 million a year in savings, not in spending, savings. So there's massive changes in that you can drive through these sorts of things, and that's that. How do we use that, Amazon? I'm going to caveat this with, I love boring tech. I sound funny saying that out loud, especially coming after an AI conversation. Boring tech is what powers 90% of the world, and I probably would say, speaking to people here that drive that kind of conversations, boring tech works. Boring tech works every time. And so that's why I personally absolutely love that. And that's this sort of conversation. When it comes to how do we scale around the world, we drive default best practices, multi-Amazon accounts. Obviously, at our scale, we hit rate limits that I didn't even know existed in Amazon. I probably won't talk through what they are, but let's just say there's Amazon rate limits that I didn't know existed or that you could hit that we hit. We have a very large edge routing network. So when you talk about data residency, when you talk about performance, control becomes a very large part of this conversation. And so things like, how do we control where this data goes? How do we control when this data is compressed? How do we control all those sorts of things? Where does it enter? Where does it exit our network? Those sorts of things. Even on something the size of Amazon, having that level of control is actually super important for us to own the performance analytics and understanding. For anyone that's done large-scale web, understands how unreliable the internet is. I never understood, I knew it beforehand, but after seeing you deploy us deploy things at global, Australia is great compared to some of the other countries around the world. We make heavy use of things like CloudFront. For those that haven't seen it, there's a lovely talk, I'm happy to send the link around, but where Slack actually talk about doing something similar, where they front their API acceleration with CloudFront. Things like TLS become a problem when you're doing global and things like that. 90% of Atlassian is deployed on EC2. I know that sounds really silly and counterintuitive in the world where we talk about Kubernetes and things like that. As per a conversation I was having with Alan earlier tonight, Kubernetes is not the solution for every single team, and it's not the solution for 99% of teams. I caveat this with, we are looking at it. We do have Kubernetes solutions deployed internally. The difference is I also have teams, we have teams internally that drive that conversation. Kubernetes makes sense at scale. Kubernetes does not make sense for a 5-person startup, unless you've got really, really interesting requirements. Things like data storage. We take use of data storage on Aurora. We take Dynamo, we have S3. It's really boring, but it works really well. The part that we do that's different is things like data residency and things like that. Dynamo and S3, they don't have that as a solution by default. So we have internal solutions called Transactional Data Platform, where we built a platform over the top of Dynamo and S3, and that handles all those data residency and similar requirements for our teams. We use that instead of using Dynamo directly, and that handles how you handle the kind of distributed. If I understand correctly, and although I haven't got it recently, I believe Amazon actually has an internal platform very similar that they use as well. So yeah. But basically, we just use the default standard stack of Amazon at a much larger scale. For things like deployments, we actually use CloudFront under the covers. 99% of it of Atlassian is deployed as CloudFront on Amazon. It's boring but works. We have, and it's public knowledge, we have a stack internally called a service internally called Micros, which basically orchestrates this for us. And this is where I get to the level of like what we do versus what others do. Most teams would go and use something like CDK, and I believe people like Canva and others do that. In our case, we have a solution like Micros, which actually abstracts a huge amount of Amazon from us, not completely, but a large portion of it. And it solves a large amount of our compliance and deployment problems because it understands how to deploy a solution correctly and securely, meeting all those data compliance requirements from earlier. Cool. Scaling around the world. So when we go around the world, there's a couple of things that come into mind when you have to deal with these things. And I think Alan actually asked me about this earlier, was like, what happens when a region goes down? So we deploy in a sharded architecture pretty much every single service. If a region goes down, very rarely we actually have a hard requirement internally, that if a single region goes down, the rest of the things work. All your core pieces of the products are all up and running and no issues. There are obviously some caveats to those conversations, but on the whole, everything is up and running. This is something that again, at smaller scale, doesn't always make sense to do. But at the scale we drive, sharding and driving that makes sense. And this is where if you do things correctly at smaller scale with infrastructure as code, CDK, and abstracting out some of your stuff, driving down these conversations in the future become a lot easier. And that's where we definitely come from in that one. Internally, we use Spinnaker. Again, this is about, for us, we standardize, build, and deploy across every single thing. I don't know the last count, but last count it was in the thousands of services that we deploy globally. They need to be deployed in a compliant SOX and all of the other compliance standards that we need to adhere to. So this is how we drive those conversations and how we get that across the world. And the other one is obviously because we're using a sharded, well not obviously, but because we're using a sharded architecture, we also have a giant service proxy layer that goes across the world. And so that allows us to route around problems from a single place versus needing to kind of every service understand how to do that. There's another one that I didn't actually have in my notes originally, but I remembered before. There's one thing that comes with global scale and one thing that I was reading about recently, I think it was Planet Scale wrote about running into problems with EBS volumes at scale. And it's the same problem we run into when running API requests at scale across regions. We do not just server-side load balancing, so in a load balancer situation, we actually quite regularly will do client-side load balancing between regions, between different failovers. No offense to Amazon. Sometimes they take their time to get the failures right, or it doesn't quite fail in a consistent manner, or it's a performance impact, not an actual outage. And so by using client-side routing, we're actually able to react very quickly to some of those problems and route around them. It's definitely something, as also some of our very large services, we have some very core services that are involved in like every single request that handle hundreds of thousands of requests per second in each region. Those use client-side routing as well, and client-side load balancing to kind of shard themselves out and not take on everything. Cool. Oh, the other one, and I've got this really interesting question to see if anyone knows the answer to this, because it was a fun problem we had to deal with internally with our service proxy. We had two regions. We had a service that connected and talked to different regions around the world. P90 was in the 50 millisecond range. P99 was in the 450 millisecond range. So it added about 400 milliseconds at our thing. Does anyone want to take a guess as to why? Because I did not get this one. I had one of our networking team had to pick it.
Just because?
Pardon?
Just because?
Yeah, kind of just because. It was actually a really small change in one of our services.
What was the service doing?
It was just making a HTTP request between two regions.
Nothing fancy.
No, nothing fancy. It was literally between a Java service to a ALB. Yeah?
So global accelerator?
Nope.
Garbage collection?
Nope. Kind of related to garbage collection. End up being connection timeout. Turns out the time it takes to establish an SSL connection between two particular regions takes between 300 and 400 milliseconds in some situations. And so it was literally what was happening was, if we didn't have enough traffic between those two regions for a short period, it would drop the connections and we'd be done. We literally changed the connection timeout from 60 seconds to, I don't remember, it's over like an hour or something. Our P99 dropped back down to like 50 or 60 milliseconds. We instantly dropped that out. I've been doing Amazon for a very long time. I spent ages, and I actually argued with our network admin around it, going, there can be no way that that's the problem we're dealing with. Sure enough, changed the setting, done. Instantly dropped it. That's the sort of problems that you start to run into at scale between multi-region. And that's why, like, I say you are not Atlassian, because even I look at that and go, that's crazy. I cannot believe that that's actually a problem we had to deal with.
Took it in terms of time to find that. How long did you bug that?
From when the team first started, which was before I rolled onto that problem, it would have been over a month. Yeah, how long did it take the person who's the senior principal for that area? About 2 days. So literally it was put the right person in the right place and they were able to debug it very, very quickly. But it took a very senior part of our team to actually be able to come in and solve that problem.
I can imagine, because it goes through the entire stack as
Well.
well.
So it was between services owned by multiple teams as well. So we have a service proxy team. I have a core networking team. We also have the team on that one side and a team on the other. And so we had to kind of work out somewhere in that stack, that conversation happened. And it took a very long time to go, okay, so it's not that service, it's not that service. And by the time they got involved, we had kind of worked out roughly where it was. But yeah, that's the sort of problem we deal with. The other one that I've got that's a fun use case is how do you securely provide CloudFront access to content that needs to be protected? And that's another one that we had to work through because CloudFront obviously by default is just open. And so, yeah, there's different ways of doing that. Amazon have a really lovely solution with their signed keys and things like that. But that also becomes a pain in the ass because you can only have 2 signed keys per CloudFront and rotating them becomes an absolute pain in the ass. But there are solutions, there are ways around this. Things like Lambda at the edge, things like CloudFront functions. Again, there's other fun problems with that when you're doing this. But yeah, there's definitely other ways and things like that. And this is where like data residency for that, you had to go through, this is one of the fun problems I get to deal with is sometimes making these changes is not a technical hurdle, but a legal hurdle. And like involve many conversations with our lawyers. That is the fun part of my day. But yeah, so that's why we standardize a large portion of our tech stack is because these problems, like that one I described around the network latency we fixed for every single team in one go. It was like, okay, that's the problem. Let's go change the connection timeout on every single service, on all of our load balancers, on everywhere in one go. And Micros is something that allows us to drive that sort of change. I don't believe I've seen that in any other sort of solution. Even CDK runs into the problem if you need to have modules that then get deployed later and things like that. So yeah, but yeah, that's the sort of thing.
When you say, sorry.
No, you're right.
Question,
You go.
that's okay. When you say that and you roll that out for pretty much every instance like in the world or in every region that you guys operate in,
Yep.
How long does that take? Where do we sit in terms of like cap theory, like it being eventually consistent and rolled out to all of those regions and available for all of those clients as well? Like how long does it take to you?
I'll give you the consultant answer. It depends. It really does depend though. So something that's a smaller change where we may not control both ends can take weeks and months, or where you're not sure about it can take weeks and months, and we'll do like region by region, or we'll do, we have multi-tiered servicing architecture. So we have tier 3, tier 2, tier 1 and tier 0 services. So we tend to roll it out for the bottom tier first, globally in a rollout, then one up, and then wait. A lot of the time we'll then have to wait and go, hey, is this okay? Other tiers of services or the higher tiers can then, like, so for example, my service is tier 1 and we're currently in the middle of moving to tier 0. We will either opt in or opt out of like which ring and things like that. So short answer, it depends. It can, if something was wrong and we had to rapidly deploy it, we could redeploy some of that stuff in minutes, some in hours. For something that's very, very large like that, like a massive network change, it takes weeks and months. But yeah.
More compliance thing and making sure that you got your bases covered rather than...
It's not compliance because it's still just an architectural change. That's fine. It's the risk of it going bad. If you make a mistake to every load balancer that we deployed, which I don't actually know the number off the top of my head, but it would be a very large number, rolling that back, this is where I was saying, like, we run into Amazon API limits you've never seen. We would probably take Amazon offline, in which case, one case, I won't say which service or which region or whatever. I have been alerted in a previous part where Amazon have said, you're hitting our rate limits now, we're about to rate limit you. So like, that's where you run into some of those conversations of it's actually not even necessarily how fast we can do it, it's how fast we can push it to Amazon at the size and scale we drive. And it's a safety thing more than anything, because as you can imagine, if I go and take all of Atlassian customer base down, half the engineering force in the world probably stops working. So they're also probably at the pub having a great time, but half the engineering force in the world probably stops working when we take something like Jira offline. So yeah, that's why it's more of a conversation around that. Cool. How do we structure services? So this is one where I've seen many different conversations in my time. I've been an engineer almost 20 years now, a bit over 20 years now. So when I first started, engineering was heavily, you had your compute close to your data services, you had stored procedures in databases, you had all of that stuff pushed as close together as you possibly could. I've watched the fun of, we pushed it all to laptops and we run React on the browser and we just do API calls, to Vercel is now pushed for a while. We're going to go to Edge and we run the Edge and it's nowhere near your database, to now we're back to co-locating compute and data because, hey, there's one API request, there's 50 to 100 database calls. This is one where what we run into is, and I was describing with Dare, is that fun problem. I can run the server-side rendering for Jira globally, we do. But realistically, this is where our edge routing network comes in, and this is where the control we have to exert versus the internet comes in. That server-side rendering for, say, something like Jira will actually run next to the database versus running anywhere, because the number of API calls, the number of data pieces it has to gather, the number of everything it has to do is actually way faster. So that little bit of extra latency across multi-region is actually less when it's the single API call versus the many, many data ones. Mentor of mine, I love stealing it from him, but I wish I had a picture for you. Sorry, I forgot to grab it before this. He calls it Mullet microservices. It's great fun. HTTP up the front and messaging or SQS style stuff at the back. It's a really great way to run. I've talked to people that work at Google. I've talked to people that work at a bunch of other large tech companies as well. It's actually a way a large number of teams actually end up scaling. HTTP scales really well at a low level. When you want to talk between services, HTTP is super simple and easy to implement. And I don't have the maths in front of me, but when you start working out the 99th percentile to failure, 1% of failure rate becomes really big when you cascade down 3 or 4 levels of HTTP. So basically, anytime we can, everything is moved off that critical path of HTTP. So we have a mix. Our HTTP is mostly GraphQL these days. We have a giant GraphQL aggregator. It genuinely makes life really awesome. I never thought I'd say this, but I actually really love GraphQL when you have that proper layer. Again, this is that scale conversation of like, we have what's called Atlassian GraphQL Gateway. It actually lets us stitch our entire GraphQL system across many, many, many sets of services behind that and expose it as one giant GraphQL system. It's awesome from that perspective because I can query and join between multiple data sets and multiple data sources and services in one layer. And it handles a lot of that data residency and location and things like that for us. So HTTP, we try to do as much as possible in the region that it can be, in the region it's got data for. Some services implement this themselves, some rely on our service proxies and things like that. When it comes to messaging, everyone here is probably familiar with SQS. We use heavily use of SQS, Kafka, all those solutions depending on the requirements. The other one we've got, and similar to our TDP services, is we've got something internally called StreamHub. StreamHub is our enterprise service bus. What that allows us to do is data validation, permission checks on in and out. So I can actually say which services can and can't publish my messages, which ones can and can't listen to my messages. Gives us a lot of data governance. But it's also our multi-region scaling solution for messaging. So obviously SQS is a pain in the ass to make work multi-region and all those sorts of things. StreamHub solves that for me because I just publish to my local StreamHub and someone else can subscribe and say, I only exist in US East 1. I want to get every single message that gets published for this anywhere in the world. into my service in US East 1. And StreamHub understands how to handle that conversation, how to drive the things. We've had, in my entire time at Atlassian, we've had one pause or delay in those, and we lost 0 messages. They all arrived, they just arrived a little bit late, but that gives us that data guarantee of how do we do multi-region messaging in a way that's reliable and shifts the thing. There's one thing I actually forgot to call out earlier in regards to messaging, and it's an interesting one that people forget about, and this is around the performance thing and HTTP. I won't say what the service is. We have a service at Atlassian that was doing some work. Deployed in one region, the batch job that it gets over SQS, it gets through that job in, I don't remember the exact number, but from memory, it was something in the realms of 10 to 15 minutes. This team then had a second one where they deployed the exact same service, like exactly the same service, connected to the same data source in the same region. So both were connected to their local data regions. One was just deployed in, let's say US East 1, and one was deployed in Europe. It takes 15 minutes to deploy and to run the job in US East 1. It took over an hour to run in Europe. And this is where the conversation of like HTTP becomes an absolute pain in the ass. Literally came down to the network latency between Europe and US was high enough that all of those jobs slowed down to the point it took 4 times as long. This is that conversation of like, why not HTTP in a lot of cases? This is one where I will firmly say, and like Damien is a consultant, used to be a consultant for Redify, which is now Telstra Purple, and does his own consulting now. And I've seen this in the world before I came to Atlassian as well. This is a pattern that scales amazingly well at the small scale. And after seeing it at large scale, it scales even better. And so like the wins you get out of making sure you follow these patterns and making sure you follow good best practices around messaging and HTTP and what to do when, scale better the bigger you get, but that doesn't mean don't do them at the small scale, please. Saves consultants coming and fixing this problem later. Cool. One last caveat I'm just going to call out here because it's another thing that I will say, and I've seen teams at Atlassian make this mistake, and the Amazon consultants in the room will laugh a little bit at this because I've worked with most of them and I know this. Please understand your bill. Please understand how to read like things like your usage reports and things like that. I had a team that literally was spending, I won't say how much, but a big number. And when I asked the team, how do we save, and literally just went through the current usage reporting, how do we save money on each of these line items? They actually said to me, the second line item in their thing, I don't know what that is. And it was a big number. And I said, what do you mean you don't know what that is? And it turned out they just never seen it. We ended up solving that problem using CloudFront because it was a multi-region problem. When you shift data, even across Amazon's network at large scale, it ends up costing a big amount of money. But make sure you understand your bill and understand why you have the items you have. When you're building something, please think about what that's going to look like if you ever got a scale event, 100, 200x. It's not to say don't change your design. It's to say understand what it means if it does. Because boy, does that save your SAs a whole lot of conversations later. Although Amazon love your bill when it does that. So yeah. But otherwise, thank you very much. And again, if you have questions, have a chat to Steve about recruitment.
Any questions?
Yeah.
Yeah, just wondering, so is there a logical split to how your teams are split across the world in terms of the services you're managing? So for example, are we managing Jira here in Australia or parts of Jira in Australia?
Short answer is yes and no. So Atlassian is a very large enterprise, like engineering team. So we're split and we're split into, I don't remember how many geos, but roughly our 2 major ones are AU and US. Short answer is yes. On the whole, there are areas that are localized, but when you start talking about how many engineers work on Jira, as in all the Jiras and everything, no, because it's just too big. That's the short answer. But like, for example, I have 3 teams that work for me personally right now. 2 are in Australia, 1 is in the US. Any individual team must be kept inside of a 4-hour overlap. So I can't say build a team in like in Brisbane and then in New York. I can't split a team over that sort of size because that's just not fair. For those that aren't aware, 9 a.m. in New York is midnight in Australia. Don't ask me how I know that. Or why our translation team's in New York. So short answer is for smaller teams, no, we don't. But when you start talking in the hundreds of engineers space, yes, sometimes they do. But a team will be localized and most of the people in an org or an area will be localized. Sometimes those teams, like Jira itself, is not one team. It's 2 or 3 orgs. So yes, they do. They are spread about. Yes?
A question about the last comment about teams looking at your build, right?
Yeah.
So in Atlassian, is there a central team that looks at the build or they actually push it out to the engineering teams to have a look at the bill and then keep optimizing on a continuous basis?
Both. So we have a FinOps team,
Right.
and that FinOps team's job is to manage negotiations with Amazon for our account, bills, all those sorts of things. Manage. So, for example, my team and teams in Atlassian, unless they've got a particular requirement for it, don't manage things like compute reservations, because the size and scale we do, we have wholesale agreements on that. It's not like reserved instances like most teams, like most companies would do. So we have a team that manages that. But when it comes to like specialist things, so Elasticsearch, Redis, those sorts of reservations, yeah, your team manage that. And your team's ultimately responsible for those. Like, so I have a team that had Elasticsearch. Every 12 months, we'd have the conversation with the FinOps team. Hey, do you need to renew this? What do you need to do? Do you need to go for this long? Is it going up? Is it going down? Those sorts of things. One of the ones that amazed me starting at Atlassian was like, coming from iTalk and that world, was if you need to change a reservation, most people don't know this, but you can actually go to Amazon and say like, hey, we're 6 months into this reservation. We've actually realized we need a bigger instance. Can I cancel that one to get a new one? And they will actually normally have a conversation with you about it because you're continuing and you're making a bigger reservation. You're not just canceling it. Not all teams were aware you could have that conversation. And so like, that's where the FinOps team comes in, is like, hey, that's our internal thing. The other part is, while they're amazing, I only have 2 SAs for the whole of Atlassian. So we do have internal teams like our FinOps team and some of our cloud services teams that take some of the load off the Amazon team. I love our team, just to call that out. Absolutely love the team. And I have a great relationship with our SAs. But not all of our engineers need that level of communication. And so, yeah, so short answer is both. Our FinOps team actually do push out as part of, we've got weekly like operations reporting that goes out to every team. If your bill goes up or your bill goes down, we get alerted. So if your bill goes up by more than, I can't remember the percentage, sorry, but if it goes up by more than, you actually get an alert to get raised, and your team has to mitigate that, or it raises a FinOps incident, and then it actually has to get managed and everything like that. So it's a bit of A and a bit of B. Yeah.
Do you have to have an awareness or visibility of the capacity of Amazon's data centers, or can
Yes.
you just treat it as a black box?
No.
Yeah.
For 99% of teams, no.
Yeah.
But when you do something like we're going to go change to Graviton, yes.
Yeah.
Because it's not at 90, and to be honest, I've seen this before I came to Atlassian.
Yeah.
So, fun story, I used to work at an events company doing ticketing in Australia. We ran into a fun problem where all of a sudden we could not scale in a particular AZ, and we could not work it out. It ended up being that, and I don't remember which uni, one of the unis was running ML modeling on a Monday, every Monday, and they would just consume every single resource of this particular resource type, instance type, in a region. And they did it every Monday. They ended up being told not to, I believe. But it took, funnily enough, going through like OzNog and things like that to find out which university and who it was to tell them to back off. But seriously, they just went and took every piece of compute in that AZ. And it turns out And this is one that I didn't have in here. It's one that we don't do today. I can see us doing it in the future. It's definitely one that Slack and others do at scale and it's something I love and hate about AWS. AZs, and this is why this university, by the way, took an entire AZ, not an entire region. AZs are awesome, but an AZ is a data center at the end of the day. And if I go back to, and I've been doing this long enough that I built data centers, so like I remember these conversations, you never sharded your service across data centers in the world, ever. Like we've never done it till Amazon existed. It just was never done. Why? Because it's shit, to put it bluntly. The performance, the latency you introduce, all of that is shit. What this university was doing, they had a massive compute cluster that had to do a massive amount of compute. They didn't want that AZ latency, and they didn't care about failures because it was a huge compute cluster that could fail a couple of nodes and recover. So they just put it all in one region. I think it's Slack has actually gone down the same route now, where their cell architectures are now AZ affinitized with data, with replication to other AZs. And by doing that, they reduced their latency, reduced their costs, and drove a massive thing. So again, I say this from the small scale goes to big. Also look at the past, please, because there's a huge amount of learning you get out coming out of data centers and things like that to making sure you do your large deployments correctly. So, everyone? Cool. Happy to have more chats after, but thanks.
Cool. So firstly, end of the night, I want to thank you, of course, to our sponsors. So Year 11, ThoughtWorks, and AWS. So I guess without our sponsors, we can't really provide the free food, the free drinks, and just the event impossible. The event, really. So thank you very much. But going to the fun things. Cool. So the next user group, we're doing something a little bit different. So we're going to be running a hands-on workshop with AWS Direct Connect and Hybrid DNS. So this is going to be great for people who don't get the chance to build out the Direct Connect or the DNS solution. So please come along. We're going to be using all the rooms. We're quite excited for it. It's a bit of a learning opportunity. We also want your feedback on how it goes. We're trying something different, not a day-to-day talks, but please come along.
And these are like real direct connect. You're connecting the direct connects to actual on-prem, provisioning it from scratch, and full network path and everything. It's not a simulation.
Yeah.
There'll be networking people in the room.
But yeah, please come along, join, get to learn something new. Always fun. Next one. I know there's people, regulars here, who like to present. But if you're new, you want to get involved, please let us know if you want to present. We are always looking for speakers. We're always looking for a backlog of speakers. Do you have friends who want to speak? Whether you're new to public speaking, like, I'm not going to lie, I hate public speaking, and I'm standing off here. It still gives me the heebie-jeebies. But this is a safe space, so if you do want to talk, please come along. Please register. We'd love to get as many people in Brisbane around to chat and present maybe their ideas on AWS or what they're building internally or at work. Next up, you would have seen all the recording gear. We have a YouTube channel, so if you want to go back and look up previous user groups, we have a channel. Join along. We do poster sessions at the end of the events, a couple of days after the events.
Don't me to that.
Pardon?
Don't commit me to a couple of days.
When
Within
Ryan,
a week.
when Ryan feels like, when Ryan's free. But yeah, no, we have a couple of months worth of presentations up there, so if you want to learn something new, missed an event, feel free to join. And then, yeah, we have Slack channel, so you want to chat. We post all the if you have jobs that are upcoming, we post them in the events streamed directly from AWS, so the What's News, but also posts directed from community builders worldwide. And then also the organisers, we also post when we're going to another event, so please join along.
Outside because the door's locked at 6 o'clock.
Yeah.
If you need to come in, that's a good one to get in contact with us.
Yeah, and then we can send an AWS Mr. Mark in the corner to go collect you. Cool. And then, yeah, finally, thank you. If you have any feedback, please let us know. We are always looking for feedback. We want to make sure that we are bringing the best event we can. Alternatively, if you don't have any feedback, or if you don't want to put it on a post or a Google form, please come and talk to us directly. We are always keen to learn more what you guys want to see. The events about building a community in Brisbane for AWS. So, yeah, that's it. And yeah, thank you. That was the last slide. And have a great evening and enjoy the rest of your week.